Hello, welcome to the Dev Method. My name is Ricky. We are here today to continue on the 100 exercises to learn Rust. So we're taking a look at each of these chapters and we're going to review it at the end, see how you like it, and maybe share with you some things that I learned along the way, because there's always something new to learn, right? That's what we're going to do today. I'm going to bring up the website here for you. So the link's in the description, but here's the GitHub. Okay, 100 exercises to learn in Rust. And in this exercises directory, there's a bunch of these different sections or chapters. And that's where you can go and you're doing all these different exercises to learn like enums or the if else or all sorts of stuff. So this is a great way to learn if you need something interactive. And I found it to be pretty good. And I didn't make this. Some guys at rust-exercises.com did. So check them out if you like what you see here. Also, along the way, we'll be looking at a solutions branch. So either sometimes you get stuck or we're not exactly sure what it is, how they want us to solve something. So we can go there to get the answers. So for example, here it is, solutions. There's also a rustexercises.com/100 exercises. And it's like this little follow along book, a little bit more explanation than what we get in the code. But yeah, so today we'll be looking at, we'll start with arrays. We'll move on to vectors, resizing, iterators, and then we'll move on from there. We'll see how far we get. And if you have any questions along the way, just put it in the chat and I will do my best to answer them. The chat's like 20 seconds behind, so just give me a little bit of time there. I'll be checking back every so often at the chat, see where we're at. So there we go. That's what we're doing today. All right, let's dig in. Okay. Let's do... Oh, I realized you weren't seeing my screen before. It's okay. There we go. Let me show you one more time, the website, what it looks like. There's the GitHub. There's the website. We'll come back to it every so often. All right. So here I am in the in the repo. And I'm going to go to exercises. We left off yesterday with the outro to tickets v2. So let's just take a look at that real quick. So yeah, all these things that we did. Let's look at the outro. So we had many different files here and we had instruction on what we were supposed to do. There's a lot of errors when we open this up. So we went through each of these modules, description, status, and title. We looked at their corresponding struct that was there. We created some sort of validation error handling. And we did an implementation of try from, because a lot of these are properties that are stored as strings. So yeah, but then we wanted to compare to strs. So there's all these different tests that you run in these projects. So when you run the test, that's how you know if you can pass to the next thing. Sometimes it's about just clearing the errors. Sometimes there's not a test at all. So yeah, you just kind of try to follow the instructions the best you can. That's how we're going to do it. So let's move on. We're going to go to the management. All right. Just in case you're wanting to see what's ahead, these are some of the words. Yeah, let's see how far we can get. Let's move on to intro. All right, easy enough. The intro is always easy. You're just replacing strings here. I'm ready to build a ticket management system. Okay. And I guess for this one, I'll go test, right? Cool. Everything looking good. Okay. So let's go to arrays. All right. Flesh out the weak temperatures struct and its method implementations to pass the tests. All right, let's take a look. Let's scan. Here's our to-do. Fill this out. We got enum of all the weekdays. Okay, and then we have some methods associated with week temperatures. Got a new, got a get temperature. Okay, let's go down further. All right, we got a lot of tests here. So get temperature. So you create a new temperature and you get the temperature. But the temperature could be, it looks like it's an option of either some or none. And here's our assert equals. Just go up one more font size. There we go. Okay, so set the temperature. I guess we need a temperature, yeah? So and then we need a day, which is going to be a weekday. It's funny, it says weekday, but then I see some weekend days. So maybe it should have been day. Doesn't matter. All right, new. We need some default values, I suppose. Okay, so if we're always going to return an option, I guess this is going to be an option. So option, like so. Oh, I see. We're doing arrays, so this is not. Yeah, so this is going to be like this. Yeah. Self. Let's implement self, or a constructor for self. Okay. Date temperatures. We'll say it's none. Yeah, I don't know what to call this. I called it day, but it's days because it's many of them. Okay. Can we do that? What do we have wrong here? Days shows weekdays. Weekday. Oh, it needs to know the size ahead of time. Yeah, that's right. Yeah. So yeah, what we need to do is not like this. I realize now that they don't have everything here. So like what we need to do is basically create like a struct here that has the temperature and it has the day. And then this is going to be like a wrapper of a collection of days. That's the idea. Yeah. So let me look here. Now that we're done scanning, let's take a look here at arrays. So here you go, right? This is how you normally do an array. You say the type, semicolon, and then how many. So we need an actual size. We need an actual like fixed size. If all array elements are the same, you can do a shorter syntax. All right, cool. So my guess here is that we're going to create our own struct. I don't even know what to call this struct. Let's call it, I don't know. I can't think today. So we'll do this for a temperature, which be an option I32. And then we'll do a day, which is a week day. Okay. And then this will be a group of 7, right? So then what we do here, just to be sure, let's say a group of 7. So what we do is we will do a group with a temp of none. Okay. And a day to weekday, Monday, like that. And then we'll do the days like so. That's what we're going to do. But what we'll do here, Tuesday, let's make this in the middle of the screen. There we go. And then Thursday, Friday. Oh boy, we're getting close. Saturday and Sunday. We're good, yeah? Did we get it? Oh. Found array 5. Really? Did I miss a day? 1, 2, 3, 4, 5, 6, 7. Okay. You are mistaken, sir. There we go. Just had to say it again. All right, cool. Wow, that's a long list. That auto formatting, man. Yeah, we are doing the streams more frequently. Thank you for noticing. Okay, so now we need to basically say when we set a temperature for a day, go find that day and mutate it, right? Oh boy, this is very long. Okay. Let's do that here. We'll say we have a group, okay? And every time we set, we're gonna make a new group. So we go group, and then the temp be the sum temperature. Okay. Oh, with a day. Yep. Day, like that. Okay. And this is where we need to do like a find and replace. Let's see. There's a couple ways we could do this. I know we have like iter and stuff like that later. So like, I guess we don't do that. All right, so let's do this. We'll find it by the day. The day is going to be kind of like the key. And then we'll find that index, and then we'll just replace that index. I think that's what we might do. So if I did self.days. Oh yeah, okay. Okay, we'll do this. This is going to be a use size of 0. We'll just start at 0 because we can't have less than 0. For item in self.days. Okay. Just do borrow here. Oh, but we want to enumerate over it. To count. Did we even do for loops? See, I want to reach for this, but I don't know that we're allowed to do that yet. Okay. Oh, this has to be mute. There we go. Oh, this has to be use size as well. All right, we're going to do this maybe in a strange way. Okay. So we go if the item dot day equals the given day, then the index equals I, and we break. Otherwise, keep going. It's going to be the idea. All right, what is it saying here? Weekday. Let's go here. Derive. Can't wait to see what the answer is. Or what this proposed solution is. Okay, day. Can't use day because it's already been moved. Yeah. Okay. All right, we need to do like a copy or clone or both. Let's just put both on there. Copy and clone. Okay, so implicitly copied into here. So we're using another copy here. Why is it saying here? What's the warning? Oh, it's saying it's not read. Yeah, it will be. So let me do self.days of the index is going to equal the group. Like so. All right, so we find the index with this. And that should take care of, what's this part? This is called the set temperature. Now we want to get temperature. All right, we'll do the same strategy here. We'll just say, okay. Are you just setting in game temperatures? Yeah, so you just got here. So let me real quick show you what we're working on. We are working on this 100 exercises in Rust. Okay, so I didn't write this but it's open source. It's right here for everybody to try out. And it's got a solutions branch. So we're going to take a look at the solution. And we've been going through a couple of these in the last couple of days. So just to show you here, there's the intro, the basic calculator, ticket V1, traits. Let me open up traits just to show you an example. Derive, deref, okay, and then tickets V2. Got some enums, matching statement, if let, mutability, all sorts of stuff like that. Now we're in ticket management, and we're on arrays. So I don't want to go too far ahead because I see that there's iterators and iter here. So yeah, just trying to solve it the way that I can do it without, I guess, exposing the information that we're going to find in the other upcoming sections or chapters. But I don't know what's coming up. This is all off the cuff, but that's the idea. And so they also have a corresponding website here. It's rust-exercises.com/100exercises. And they give you a little bit more detail about what you're expected to do. So we get in here and we look at the to-do at the top, and we can read what the instructions are. And right now, all it says is just, implement to pass the test. So that's the idea. So I can look down here. Oh, sorry about moving it really quickly. I can look down here at the tests and just try and see if we can fill in the implementation. Yeah, so I think the temperatures, what they're trying to do here, if you look at the highlighted line that I have here, there's a set temperatures and then there's a get temperatures. So when you set the temperature, you set it for a particular day. So this object called weekly temperatures is set on this line here. That's our mutable let. Okay, so then it's going to alter the state, the internal state of that struct with set temperatures, and it has its corresponding get temperatures. So if we set the temperature to Monday, which is an enum that they set up for us, to the temperature of 20, we should be able to then call get temperatures for Monday and receive an option of I32 back, which in this case, we want to make sure it's the same value that we set it with. So that's the idea. So that's what we're doing here. And then they have another one where they set, again, Monday to 25. So we should be able to get 25 out of there. Then they're going to set all the different days of the week, make sure Monday is still the same as it was before, then get Tuesday and so on, and make sure that those values are all set too. So since we're working on arrays, I'm saving here's the week temperatures, saving the days as 7 elements to fixed size here. And we have group, and then we have this thing called temp. That's what we're doing. So we're filling out the implementation. If I scroll down below, I got the new. This is my new. So I always just set the temperature to none for each of the days. And now I'm here on get temperature. I already did set temperature. Now I'm getting the temperature. So I'm going to do the same strategy I did before. I'm going to find the index. Okay. And then we'll do for item in self.days. Just going to find that if the item equals the day, then we know what index it is. So we'll say index equals I, and we break, else I plus 1. That's what we're doing there. And once we have that, then we can get the item. I suppose, actually, if we find the item, we could just return its temperature here. So we don't need to do that. Yeah. There we go. So at the end of this, we'll return none if we didn't find it, which we shouldn't ever run into that, but the compiler is going to want that. So if item equals the day, and return the item dot temp as some value. There we go. Okay, what do we got wrong here? Oh, item dot day. Yeah. All right, and then this probably, because it wants this. Oh, getting closer. Whoops. Oh. Oh, I found an option. Oh, yeah. So I'm just wrapping it again. So, yeah. Because that is an option 32. Yep. Okay, so that's how we return it. So I think we did it. Now, at the end of this, we do a test. We run the test, and we see if we got it all right. So cargo T. It looks like we got it. Nice. All right, we're going to be moving on. Okay. Going on to vectors. Let's take a moment to pause. Did a good job. Have a sip of coffee. Have some water. Do something so that you're ready for the next one, because now we're moving on to vectors. So point out the arrays that we just did and vectors. Sometimes these names, depending on the programming language you're in, somehow they overlap, somehow they're the same, sometimes they're not the same. So yeah. We're going to see the difference here with arrays versus vectors. I'll tell you right now, the first thing that I always think of is with an array, it's a fixed size. With a vector, you don't know the size. You might know the size because you coded a hard-coded array, but it's also possible that you're passed in a vector and you don't know the size. And so it needs to grow, it needs to shrink. That's the idea. The vector, you'll see it. You'll see it. In fact, let's flip our page in our book to vectors. Let's just see here. Maybe they have a better way of describing the differences. Yeah, so they said this is arrays. Yeah. You'll get a compilation error, see, because you need to have the size of the array. So what do you do instead? You use a vector. So here's how to create a new vector, or one of the ways to create a new vector of a U32. Okay. And since it's a mutable, you can push more values onto it. Okay. It's kind of like a stack in that way. This is also the shorthand. This is what I usually write, the macro for vec. And then it infers what the type is here because we didn't specify on the left-hand side the type annotation. And you can get the element by index. These are all U size, so they can't be less than 0. This is U size. And you have some really cool things here. So like here's a get, and this returns an optional. So instead of getting directly like this subscript here, where you're saying, get me the 0 element of numbers, you can call a function of .get, and that will return something. So it might be something or nothing. So it'll show you here, they're comparing it to some number, and that should be true. And if I get 3, so 0 to 3, but 3, see, is outside the bounds of this array, and you do a get, it's actually okay. We're not going to panic at runtime. We're still returned an optional, so you get none. All right, so they got memory layout. I don't know that we need to know this part here, but let's see. All right, a capacity of 3, only push 2. That's fine. The last thing here is unknown. Oh, here's another good thing to note. These are on the heap. The vectors are on the heap. Yes. Vector keeps track of 3 things. The pointer to the heap region. That's what they're showing here. The length of the vector. Whoops, didn't mean to go back up. The length of the vector. And its capacity. Yeah. How much space is reserved on the heap for this vector? Because nothing else is going to take up this space. Because you said, I needed 3. Even though you only used 2, you said you needed 3. So there it is. Here's how you could put it inside of a property for a struct or a field of a struct. All right, so it's actually a good little overview of what we need to do. Let's go ahead and move on to the exercise. And let's look at our to-dos. All right, given a number n, return the n plus 1th number in the Fibonacci sequence. Fibonacci. Fibonacci is defined as follows. I thought we did a Fibonacci. No, we did a factorial, not a Fibonacci. Okay. Okay, so the first number of the sequence is 0. The second number is 1. Every subsequent is the sum of the 2 preceding. So the sequence goes, shown here, 0, 1, 2, okay, 3, okay, it's 5. 3 plus 5 is 8. 5 plus 8 is 13. 13 plus 8 is 21, and so on. So we expect Fibonacci 0 to return 0, Fibonacci 1 to return 1, Fibonacci 2 to return, and so on. I think, so use a vec to memoize the results you already have calculated so that you don't have to recalculate them several times. Okay. I think what it's saying is like, you have previous value and current value, I think is what they're trying to say. All right, for this one, let's go back here. And I'll just show you, if we go to the solutions branch, handy dandy solutions branch, it's going to show us exactly what we want. So, right, here's the vector. Here's the vector project, right? Go to source, and we go to libs. We'll see it right here. All right. So yeah, notice this. Okay, so there's some casting involved here, right? So if, let's take away this. N equals a U size of N. That's the idea. And then we have a memo array, and we we initialize with the first 2 elements. That's what we needed. Okay. So memo, we're gonna say it's a vec of U32, and we'll go like so, 0 and 1. So far, so good, yeah? Here, just return 0 real quick. Oh, there we go. We have as U size. Okay, wasn't sure if we needed that part. All right, every time I save, it does another build for me so I can see. All right, and then we're gonna start at 2. That's what we need to do, okay? And we're gonna push the new values on, right? And then we return the value of N. So like so. I'm going to put the explicit return here, like this. Whoop. Oh yeah, so memo, make sure it's mute. Okay. So we push on a value of whatever. So like the first iteration through this loop, right, would be that I is 2. Okay. So 2 minus 1 is 1. So we take this 1 plus 0, because that's what this is. 2 minus 2 is 0. And we do that for n times. And then we take the nth element of that array. That's what that is. Nice. And that's our Fibonacci sequence. That's one way to do it. It's only one way to do it. I'm curious if you guys have other ways to do it. But this is probably like what you could do with the vector. So that's that. Let's run the test. I'm sure it works because we just looked at the answer, right? So let's do cargo T. Nice. All right, we're good. So I think that the thing to note, if we didn't add this, okay, it is still inferred what the type is, but we do need the mute. We can't infer the mute part, okay? And it is inferred, this is just a Rust thing, but it is inferred because of its usage here. Actually, let's see. How is this inferred? Probably from the return type, actually. Yeah, so if I did a return 0 here. Yeah, there we go. It thinks it's an I32. It's kind of cool, right? That's why I leave this type hints on, because I just want to make sure that I understand this. Yeah. Okay. We're in. Next, let's just move on. All right. Now, we want resizing. Okay, let's see what resizing is all about. Oh, just a test. Okay. Capacity 2, push on 2, push on 3, needs to resize. Can you guess what the new capacity will be? Be aware that the standard library makes no guarantees about the algorithm used to resize the vector, so this may change in the future. Okay. Yes, it is this resizing, because it doesn't fail. I'm thinking it's 3. And that's only because I've seen that in other programming languages. I don't know what it would be. This is actually really cool. I would love to know the answer to this, because I don't know. Oh, it's 4. So it doubles it. So original capacity 2, 4. Okay. Now I kind of want to play around with it just to see that it is a doubling. So like, let's do for I in 0 to 8. v.push I 8, 8, push 100. Not 100 items, just the number 100. If it is a doubling, it should be 16. Let's see. Why does it say right 8? Oh, because we reached the capacity, right? Oh, let's do that. Cargo test. Yeah, okay. I did 1 past 8 for the count. I needed to do this is inclusive, so index 0 through 7, which will be the count of 8. Okay, so it was 8, then I pushed one new thing to it, and then it doubled. So I was right. It is doubling. So it's doubling. I believe in other languages like Swift, it doesn't double. And if it does double, maybe there's a threshold to when it doubles. But this was years ago that I checked that out. I don't know if that's the same. But that's how it is in Rust. But the algorithm used to resize the vector is not guaranteed. It's not guaranteed the algorithm. They might use a different algorithm later. So yeah. All right, let me take this out. Just leave it like so. Go T for test. Okay. Let us move on. So that's the resizing that we needed to know about. Iterators, fun stuff. Okay, iterators. We have ticket fields, ticket description, ticket title. All right, let's start sketching out ticket store. Okay, first task, implement into iterator on ticket store. Okay, to allow iterating over all the tickets it contains using a for loop. Okay. You shouldn't have to implement the iterator trait in this case. You want to delegate the iteration to the vector field in the ticket. Look at the standard library documentation for vec to find the right type to return from into iterator. Okay, I would love to see how this works. Let us go here, go to the next section. That's resizing. All right, iteration, right? So we did a little bit of iteration. I just showed you that. Same thing for arrays, works the same way. So under the hood, it is using iterators. All right, so every time you write a for loop in Rust, the compiler desugars it into the following code. Yeah, okay, I could see that. So this loop means it's always forever looping until you break. And therefore, if you're always looping, you're calling the next thing. And if the next thing has something, then you get the item. So that's what this is here. But if you don't get that item, you have some. Or you have none. So if you have none, then you break. That means you're at the end. You've exhausted the full iteration of this list. That's the idea. So that way you don't have a infinite loop. Okay? All right, so the iterator trait. This is what it looks like. So that's that next, and there's the option. And the item inside the array, or inside this iterator, I should say, like in this one, it was a bunch of U32s. This one was I32s. Okay. Let's go back down. So that's what would be returned here. Let's see. Guaranteed if the implementer implements the more restrictive fused iterator. Whoops, didn't mean to click on that. A fused iterator. All right, cool. All right, into iterator, which is the one that we need to implement. So not all types implement iterator. That's correct. So like the type we have in our code is called a ticket store. So we do not implement iterator, but may be converted into a type that does. That's where into iterator trait comes in. Okay. So the into iterator method consumes the original value and returns an iterator over such elements. Okay. So we're going to need to implement this. All right, one detail. Every type that implements iterator automatically implements into iterator as well. You just return themselves from into iterator. All right, so iterating over iterators, nice side effect, but you can't go out of bounds by design. Right, yeah. So in other words, this is usually faster than this. All right, cool. There are exceptions to the rule. The compiler can sometimes prove that you're not going out of bounds. Okay, but in general, prefer iteration over indexing when possible. Okay, great advice. All right, we got to implement into iterator. So I don't know. Let's see. I don't know. I've never done that. Or have I? I don't know. We're going to get some cues here. We're going to get some cues. Let's over to the side. Okay. Guess we'll put it... here's the store. Simple into iter for ticket store. Okay. And the item is going to be whatever's in our vector, which is tickets. So type of, what is it, item? Look back here. Item. Item is a ticket. Item is a ticket. So we know that much. And type into iter is going to be a vec. That's ticket. Think that's what we need? Yeah. Okay, right? Iterator is not implemented for vec. Okay, yeah. Then what am I doing? All right, we're going to take a look at the answer. Oh, an into. Vec into for self item. Okay, sure. So that's from the standard library, vec, but then into iter for the self item, which is a ticket. I could just write ticket again, I think. Yeah? Could just write ticket. Let's see. Ticket. That's what I'll do. Okay. Now from here, it's just into iter for the tickets, yeah? To iter tickets. Oh wait, self.tickets dot into iter. Okay. All right. Yeah, that makes sense. I mean, if it only is just tickets and we want to iterate through it. Okay, sure. Thank you, solution. All right, let's see if we can do the rest if there's any errors in our tests. Let's go down, look at the tests here. So yeah, here's the ticket store. Here's one ticket, you add it in, and you add a second one in, and then we clone the store, and then we do an into iter, and then we collect all the values. Yes. Don't forget to collect. Let me just show you here what happens. I'm just gonna call this Ricky. I'm not going to give it a type annotation so we can see some of the inferred types. So I think this will help. All right. So you see how Ricky is an into iter here? Yeah. But now when I do .collect, it gets all those elements together. Okay. But it doesn't know the type. Yeah. So it's a vec of ticket. Is the idea. Here it did infer the type, so you could do like an underscore. You'll see here, this is ticket, okay? This is ticket. I explicitly said it was ticket, but shorthand could be this. Yeah. But yeah, it's interesting how you can't do this, right? So if I see what the error is, type annotations needed to satisfy from into iter. Sure. All right, let's leave it at that. Let's run it. Have a test. Cool. Nice. Cool. All right. Looking good. Okay, let's exit this. Okay. Let's do, what did I just do? I just did iterators. Okay. So we're going to do iter next. CDO5. All right. Provide an iter method that returns an iterator over a borrowed ticket item or the address of ticket items. Just like the previous exercise, you want to delegate the iteration to a vec for ticket fields in the ticket store. Look at the standard library implementation for vec to find the right type to return from iter. Okay, provide an iter method that returns an iterator over borrowed tickets. Okay, so I think what that's saying, all right, let's go down. Ticket store. Is it this? So I'm not sure. Okay. And then it said to look here. For now, I'm just going to say option I32. I32. All right, return none. Because it said I could do self dot tickets dot iter, which is what I want to return. So I want to return an iterator of ticket. Iter mute. I'm not sure which one. Into iterator. An iter of an into iterator. Huh. Let's take a look back here. Let's look at the next one. Iter dot iter. Okay. So n has a type of a borrowed type. But we need I basically would want borrowed tickets. It was enough to use this in a for loop, right? Yeah, I'm not sure what this return type should be. I think that's where I'm getting confused. So we're gonna have to go back to a solution. Is it iter or into iter that we need to return? That's where I'm confused. Let's see what they do. An iter, but from the standard library of slice. Okay. Let's see. Slice iter of a ticket. So That means I do tickets iter, and that would work. Oh, we don't need the mute. Hiding lifetime. Mismatched lifetime syntax. Really? We haven't talked about lifetimes. Is there something here that I'm missing? I don't see this is any different. Maybe it's always just a warning. Is there a code action here? Okay. Well, that gets rid of the warning, but does it pass the test? Cargo T. It does. Let me get rid of that. Get the warning back. Cargo T. I guess I could do a cargo check. That works too. All right. Well, I'll keep it without the warning. Sure. All right. I think what it's saying is just make sure that the lifetime of this ticket, the tickets which are held by the store, make sure it has the same lifetime as the iter that we're also returning from this, because we're creating an iterator here. And it's going to have pointers to references of these items in tickets here. I think that's what that's saying. Okay, let's move on. So that was iter. Oh, and look at that, lifetimes. Right next. All right, this is where a lot of people get confused. It's okay, we all get confused by lifetimes. Okay, so implement into iterator trait for ticket store so that the test compiles and passes. Okay, ticket store. Where are you? Oh yeah, look at that. It's got the warning there again. Implement into iterator for ticket store. The item is a ticket, and the into item is a std slice. Is it slice? What was it? Iter into iter of a self item. Yeah, got that there. Is that it? Is that how I do that? Oh man, I didn't do this right. I just did this like a couple seconds ago. Let's look in here. Vec into iter. Yeah, it gets a little confusing, right? Okay, from the module vec into iter, not iterator, into iter. Okay, and then we just do self.tickets.into iter. That's what that wanted us to do? Oh, for a borrowed ticket store. For a borrowed ticket store. Okay, so do that. Oh man, let me think about this. Shared references, move occurs, self tickets, which does not implement the copy trait. Okay. Definitely confused. Let's see if we can look at the solution and understand what it's saying. So this is the trick, which I think that means that's what we got to do. Oh, got to use a lifetime. Yeah. Okay, so usually tick A is what you use for your lifetime when there's only one. But you can write something else if you wanted to. All right, so we're introducing a lifetime. And this has that lifetime as well. Okay, this has that lifetime too. And this gets a lifetime as well. Right? Is that how they're doing it? Oh, wait, whoops. That's right. This is a borrowed. So if it's borrowed, then we get its own lifetime, and that means this gets a borrowed lifetime. Getting closer. Oh, yeah. Okay, so it goes here. A, like so. And is it like this? Oh, iter, not into, just iter. From vec? Oh, from slice. Okay. That's what I thought I had before. Okay. And it's a ticket. Self into iter. Yep. And then iter. Oh boy. Standard library slice iter. Is it because this doesn't say ticket? Let's see. I love how you guys can watch me stumble and fumble. Yeah, because we introduced the lifetime, we can't use self item, it looks like. This is definitely not an easy part of Rust to understand. So I get confused by these things all the time too. And usually, yeah, re-looking up the syntax for this is where the lifetime goes for this implementation. Because basically you're kind of declaring that this is the lifetime that can be used throughout the rest of this like implementation block. And so here we're using it on a borrowed ticket or ticket store. And then the item is going to be also the same lifetime as the ticket store. And since it's a borrowed ticket store, we'll also get a borrowed ticket if we were to iterate through it in a loop. So that's how you know that this is borrowed, but then you need to put the tick A, that single quote A. And for the iter, this is where it always gets interesting because, yeah, slice, there's a lot of iters everywhere. Utility for slice primitive. Because I think if we put vec in here, it wouldn't have iter. Yeah. Cannot find that. Yeah, so it has to be slice. So remembering where all these things come from is also really confusing. So I'm glad that's why we have the book or the solutions to help us out here. So you can just get unstuck and keep moving along. Okay, let's look at the usage of this because I think that helps as well, looking at how it's going to be used, not just filling in the details. So yeah. All right, so here it is. So you got a store, and then you call iter on it, which is the method we just implemented. Okay. And yeah, so it's going to give us borrowed tickets. Very similar to what it showed here, where this. See how numbers, you iterate through them, and these are borrowed U32s. That's what N is. Okay. Here, let's actually Let's copy and paste this in so you can see this. Oh boy. Yeah, see my type hint came in? So borrowed U32, that's what we're trying to emulate here. But we're making an abstraction over the store that you can like go through its items in the store. And so you iterate through them. And just like before, we're going to use collect to get the actual result. Because if we didn't use collect store.iter, see how we just get the iterator? And then what do you do on an iterator? You call next. So then you keep calling next, right? We'd have to write our own for loop. But collect is like kind of writing the for loop. It's like almost like a map. And just getting all the items, putting it into your vector, and then you can move on. Cool. All right, let's see what else we could do next. So that was lifetimes. It's not really a big explanation of lifetimes. Definitely going to need a lot of practice and a lot more examples of that. I have a feeling we're going to run into this multiple times. So we'll start to get a little bit slower because we got to figure it out. Very strict types in Rust. Cool. All right, let's take a short break. So yeah, take a stretch, maybe fast forward a little bit until you start coding again. That is if you're watching this afterwards, not live. Get your water. Do whatever you got to do. Maybe just like look out the window, refocus your eyes. Okay. All right, let's see how much more we could do, how much more we can get through. All right. Okay. We just did lifetimes. We're going to do combinators. Okay. Implement to-dos method. It must return a vec of references to the tickets in ticket store with the status set to to-do. Okay, I get it. Combinators. I think I know what it's talking about, but we will see. All right, where's the method? To-dos. So yeah, how are we going to add this? We're going to put it right in here. So see, this is, here, let's get in the middle of this. Okay. Whoa. There we go. All right. Just want to highlight this part here. The ticket store. We're going to be adding a new method here. And we'll call it to-dos. And it's going to return a vector of tickets that are set as to-do. So the status. So see this status here? We're going to only ones that are to-do. So it'd be self.tickets. And here we go. You ready? Iter dot into iter, into iter. Whoop. Where are my methods? I know why this isn't working. Self. All right, but we're gonna do borrowed self because we're just reading data here, which means I think this is gonna be borrowed tickets and self dot tickets. There we go. Iter ready. Filter creates an iterator which uses a closure to determine if an element should be yielded. Must return true or false. Okay. So what does this look like? Like so. All right. And then our item comes in here in between these pipes. Oh, man. So if item dot status equals status to do. Oop. Yeah, I don't know if it likes that, guys. Return. Oh. Collect. There we go. All right. Maybe we could do the implicit return. I don't know. We'll see how that looks. Does that look good? That's fine, right? I think that's it. I think that's all we got to do. Oh, but did we do it right? I don't know. What's it saying here? No method. Oh, underscores to do. Okay, maybe we didn't do it right. Let's just see. Looks like we got rid of all the errors. Okay. Just keep this up here while we open up down below to run the tests, and we pass. Now, I'm not sure if that's how they want us to solve this, but I'm guessing it's something like this. Let's see. Let's go look here. Oh, it's not. It's not how they want us to do that. Oh, wait, no, this was lifetimes. Okay, so let's go back or keep going. Combinators. Yes, okay. Map, filter, filter map. Combines filter and map in the same step. Map is like, I have some videos on this. Map, filter, reduce. Everything can be boiled down to reduce, but map and filter are kind of like specialized reduce. Anyways, so let's see, cloned converts an iterator of references into values, cloning them. Okay, enumerate, that's a good one. I like that one. Skip, take, and chain. Combine two iterators into one. Take is good. What's the other one? There's take. There's like take the first ones or take the last ones or something. Cool. Yeah. All right. So here's what they got. So iterate through the numbers. These are borrowed items. Okay. Do some sort of something. And then they're mapping them. I guess they're just taking its own value and timesing it by itself. And then adding it all up together, which is kind of like the collect, I guess, in this case. Closures. Yes, closures. We're running into closures. This will be very helpful for later. This is like the bare minimum of what you would need for a closure that you could pass in. You can actually pass that in as a function argument. That's kind of cool. But typically, like what I just did, you see it with the wing braces because there's going to be multiple lines to the closure. Yeah, actually, what did it do here? It took out my braces. But yeah, it's because it's just a one-liner. But yeah, let's see. Then here's your add function, right? And then you call it. And then that's what your result. So you can call it. And right now you're delegating the call to the filter function in our example or our exercise we're doing. Yeah, so this is, let's call attention to this actually really quick. This can get confusing too. So this is inferred from the code that's written on the right. Totally fine to do that. But you can also annotate the types of the input and the output. So use this, you'd use fn and then in parentheses is the first argument or the second and third and so on. And then this is saying it returns this type here. And then you don't write it on the right-hand side. I guess you could still write it on the right-hand side, but that's the idea. Yes, and then collect. All right, once you're done transforming over the items, so basically everything after iter, this is all kind of like building up instructions. It's like the builder pattern. And then at the end, you say, okay, now execute. That's what collect does. Consumes the iterator and collects all of its elements into a collection of your choice. So yeah, we have a vector of U32 that we want. This was an I32. And then, well, I guess maybe these change into U32s. Well, anyways, yeah, so you see here they have a filter and then they also have a map and then they collect. Collect is generic over its return type. Yeah, they're talking about this turbofish, because the function can be generic on its own. And so you usually do something like that to specify what the type is, or you just put it here. It's up to you. I typically put it here just because that's what I'm used to in other languages. So yeah. So we did solve it the way that they wanted us to. I just want to double check the solution. Maybe there's something we can learn from this. No, they did it the same exact way. All right, cool. All right, we did it. So let's move on to the next one. See that one? Those are the fun ones. Those are the fun ones. Implement a trait. We've already done some of that, so this sounds intriguing. What else could we learn? All right, implement the in progress method. It must return an iterator over the tickets in the ticket store with the status set to in progress. Yeah. Okay. We've done this. We just did this. So pub fn in progress self. Whoop. A vector of borrowed tickets. So then we do self.tickets.iter.filter, right? Because that's what we did last time. Item.status equals status in progress dot collect. I'm going to save it. It's going to reformat it. Boom. I think that's what that wanted us to do. But we still have errors. So let's check the test. Oh, just an iterator. Oh, not the collect part. Okay, let's go back. Must return an iterator over tickets. So I think that, yeah, it means that we don't use the collect. Then this here, so let's say std, slice iter. of file tickets. I think that's what that's supposed to be. All right, so we got some cool things to learn here. I do want to know what is the, okay, so something that implements an iterator. Yeah, okay. So I think what this is saying, it's like a generic. So something that implements an iterator where the ticket is an item. But now we have something wrong here. Oh, slice doesn't have the iterator. So it's a tech. To iterator. No? All right. What am I? Iter? Okay. Do I need lifetimes with this? Nope. Interesting. Do we have any code actions? It says iter is not a trait. Then why did it pop up in my autocomplete? Oh, it's a struct. So once it's a slice, it's a struct. Interesting. Yeah, I'm not sure where we get this one from. Let's take a look at first this part here. Infiltrate. Yeah, so like what is this type? That's what we want to learn. Filter method returns. Oh, the iter module. Yes. Okay. std iter module filter. Okay. We don't know that I is a slice of iter tickets. But what about P, which is this part? So this is a filter. There's some sort of iterator, and then P I think is like the thing. P is a closure. Oh, okay. Anonymous function. Infiltrate. Yeah, so we're getting closer. Oh, and then just iterator? Where the item equals ticket? I think we can just do ticket. You don't need this part. Okay. Let's try that. Does it need to be this? Oh, but where does iterator come from? From slice? std iterator? Yeah, iterator. Then we don't need this, I think, right? Still not good enough. Question mark, generic? It's not a generic parameter. Return type is fixed at compile time. Okay. Opaque return type. Yeah, that's what I'm looking for. So in Swift, it's a sum. Yes. No polymorphism involved. It knows what it is at compile time. Yeah. You just don't. Okay, so they're saying you write impl and then the thing. Because if you change the implementation here, oh, I know why. Maybe this is not working as we thought. Let's do that. Does that work? I don't know. We'll have to figure that out. But you might change the different, it might not be a filter next time. It might be a map. It might be something else like a take or something like that. And then you would have to keep changing what's up here. So you're saying it's going to be at least something, some sort of opaque return type where it could be an iterator of some kind. You just don't know what kind. That's the idea. That's what that is saying. All right, I'm not sure which iterator this wants. Does this want item equals? Is that what that wants? Yeah. Right, because this is a, let's look at this. Where is it? All right, here it is. And yeah, it has an associated type item, and it needed us to specify what that item is because it looks like a generic, right? It looks like a struct, but it's not. So we need to say what it is. So if there was more, we would have to specify what they are too. So instead of like a trait implementation, now we're just doing an opaque return type. This is super helpful, actually, to walk through the two different examples. Then you get all this stuff for free. I think that's, well, when you're using filter, right? So you get all that stuff. Yeah, all right. So did that solve our error down here? Yes, it did. So yeah, now from the caller's perspective, we could do like, give me all the ones that are in progress, and then we could do like some other filter on top of that, right? And then filter out by date, only today. And they didn't have to write the API for that. So that's why that is cool. All right, so boom, test pass. Let's move on. Okay, what do we got here? We just did infiltrate. Now we're gonna do trait 2. Okay, more to learn there. I like this. I like these ones. This is actually the really good stuff to learn, I think. Stuff that I've done before. So rework the signature of ticket store, add ticket to use a generic type parameter rather than the impl trait syntax. Rework the signature of add ticket to use a generic type. Okay. Aha, here it is. So use into ticket as the type parameter, but with a generic instead of impl. So I think what this means is, oops, T, which is an into ticket. And then this would be T. Think that that's what that means? Can make it nicer to use the method as it removes the syntax noise of dot into. Yeah, I suppose so. I mean, sometimes, yeah, it's about readability. I don't know if is there a difference? Oh, I see. Worsen the quality of the compiler message. Yeah. I mean, you got to know how to read it both ways, right? So if I did, oh, whoops. Oh man, this isn't like the greatest. All right. See here on the right-hand side, that's what we did. Then I'll go on the left-hand side. This is what it was before. They are essentially equivalent, so we don't have to change the implementation. I don't know. What do you guys think? What do you think looks better? I don't know. I don't know myself. Pick and choose. Choose your own adventure. All right, so we should be able to run these tests. I'll go test. Okay, cool. Let me just double check if there's anything else extra that we could learn in here. Yep. Okay. Oh, they're doing a where? Yeah, you could do a where. Yeah. Okay. So, okay. I guess there's a third way to write this I just didn't think about before. Let me go up. So you could do that it is type T. And then do you put the where here? Where T is into. Here, just where t. Did you put the where after here? Yeah, I think you put it here. Where? Okay. I usually don't write it like this. You can though. Yeah. Okay. Yeah. I this I see a lot in signatures. Oops. This is sometimes a little bit easier to read, but when it's just T, like if it has more of a meaning, like item or element or element like that, and you do element. When it's a little bit more descriptive of a name, yeah, it sometimes looks a little bit better to read it this way. I'm gonna go back to what we had before. But it is good to remember that the compiler error messages will just look a little bit different depending on how it's written. So I like that. It's a good thing to consider. Downsides. Prefer infiltrate and argument positions. Yeah, that one is, I think, the best looking one. I like it. Can't always do it though. So generics allow caller to implicitly specify types of an argument using the turbofish syntax. Okay, cool. All right, so we're done with that one. So slices. Okay, what do we got here? All right, define a function named sum that takes a reference to a slice of U32 and returns the sum of all elements in the slice. Okay. Sum, and it takes a slice. Okay. Values will be a slice of U32 and then returns a U32. Yeah. Turn 0. That solves the compiler problems, the errors that we had. But now we need to iterate over this. Okay. Values dot iter dot sum. I think it's just that simple, but there are some things to point out here. Let's just run it. See if we pass the test. Nice. All right. Okay, so we're using the iterators, right? And then we have this really cool thing called sum. And I think that's because it's a number, so it knows how to add them up. You don't get everything for sum. When calling sum and a primitive integer type is being returned, this method will panic if the computation overflows. Yeah, okay. If those checks are enabled. Sum, let's get rid of that warning. Let's take a look at the implementation. So see how this is a vector, but then we used an array up here? Yeah, so we used an array, but we have a vector that it's being input as. So they're like interchangeable in this way. So this, yeah, you wouldn't always do this, but it makes it a little bit more flexible so that we could do an actual array and not just a vector. And that's what we see on this line. Down here, I'll make this in the center. So yeah, this sum, it's only one method. So it takes a vector, but it also can take the array, the fixed size array here. So that's how you can do that. Let's see if there's maybe a better explanation here in the chapter or in the exercise explanation. This was slices. Is that what it was? Yeah. Okay. So this was slices. All right. So going back to this idea that there's a capacity of 3, push on 2 elements, you have room for a third, right? We already remarked how string is just a vector of U8s. Okay, sure. What is the equivalent of a stir for a vec? Okay, I see what they're saying. It would be a borrowed this, an array. So it's a slice, I guess. I would say borrowed, but it's a slice. Contiguous sequence of elements. It's more commonly used as borrowed form. Yeah. So yeah, numbers. So you get everything from a vector as an array. There you go. Or you could do as slice. Yep, that works too. And then vec implements deref, so using an array of t as the target type. So you can use slice methods on a vector directly thanks to the deref coercion. Yes, coercion. That is the right word. So it coerces this. I think that's what that's saying. Surprise, surprise. Iter is not on a vec, right? So its method for a slice here, but you call it on vec thanks to deref coercion. So it's like some fancy magic that's going on that the compiler is helping you out with. Cool. All right, memory layout. A slice is a fat pointer, just like a stir is. So it consists of a pointer to the first element of the slice and the length of the slice. Yes. Okay, that's good to know. So if you have a vec of 3 elements here, then create a slice reference here. So this is saying take 2 and 3. That's what this is doing. And put it in a slice. So it's a length of 2. So it's got a length. It's got the pointer to the first element right here, because this is on the heap. Right? It's on the heap. And it's borrowed. So we got the borrow checker helping us with this too. So yeah, numbers has a capacity of 4. It has a length right now of 3. But then you create a slice. So it doesn't have a capacity. It's just, it is what it is. It's here and it's 2. 2 length. All right. So a borrowed vector versus a borrowed slice. Okay. When you need to pass in a immutable reference to a vector, prefer this. Yeah, over a vector. This allows the function to accept any kind of slice, not necessarily one backed by a vector, which is what we just did in our test implementation. Okay. All right. And that moves on to the next thing. So yeah, there's really nothing else, I guess, to say there, but cool little tricks in Rust. So where are we at? What time are we at? All right, maybe one more. Let's see. Maybe we have time for more after this too. So let's do mutable slices. Whoops. Here we go. Find a function name squared that raises all I32s within a slice to the power of 2. Okay. Squared. Let me say it. What, I32? raises everything to the power of 2. Okay. Does that pass the compiler check? Oh, okay. Yeah. All right, we're going to mutate in place. For item in values. Okay. Item equals yeah. Close. Nope. Don't need to dereference. Is that what it's trying to say? Oh boy. Love these little. Oh, but we don't need to return anything. That's this part here. Cannot mutate immutable variable. About this? And what's this saying? I think that's what we want. Oh, to the power of 2. So we would do pow 2. But I think we need to do this. Yep. Okay. Because we don't want the dereferencing of what's coming out of pow. We want the dereferencing of just this item, and then a .pow on top of that. Store it back in the item. Does this work? Let's see. It does. Is this the way we were supposed to do it? So it's mutable, right? So you could see here from the test case, you just call this, and then it mutates what you passed in, S. It's a borrowed mutable. Okay. You can only have one of these at a time. So yeah, that works. Right? Because if we did this, I don't know about that. Okay. Well, this does work. Let's take a look at what this says here. Take a vec, make it mutable. Yeah, you can change it. You're good. Okay, limitations when working with immutable borrows. Recommendation was clear. Prefer slices references. Yeah, that's what we did. Okay. This will not compile, of course, because this is a method on vec. All right, I just want to double check the mutable slices. I want to check the solution. Oh, they just did this. Oh yeah, times. Yeah. All right, so we did have it. I just did it slightly different way. Right? Power of 2. So it's times by itself. I did a pow. I did it slightly different. That's okay. Here's the other way to write it. I'll put it in parentheses. So you dereference it to store it back into that address in memory. But you basically are taking two of those that you dereference, you get the value, compute, and then store it back into here. That's what that's doing. I don't know. I'm going to write it like this. There's a lot of stars in the other one. It might be confusing to read. But yeah, that's what that is. Nice. Okay. Let's do another one. We just did mutable slices. Okay, 2 states. Interesting. What does that mean? All right, update add ticket signature so that it takes a ticket draft as input and returns a ticket ID as output. Okay, interesting. Unique ID generated by ticket store. Feel free to modify ticket store fields if needed. Okay, you also need to get method, add a get method to takes an input as a ticket ID. Ticket ID. Oh, I see. Ticket ID is here. Update add ticket signature. It should take a ticket draft as input and return a ticket ID as output. Where do we got that? Ticket ID. Is that what that said to do? Turn a ticket ID as output, as input. Each ticket should have a unique ID generated. Okay. A unique ID, feel free to modify this. All right, how are we getting that ID? Does it suggest? I'm a little lost on how we're going to generate a unique ID with what we know so far. Do we need a dependency to do this? How do I keep a counter? Okay, I guess we could just do an incremental counter. Interesting. Let's read what's on here. We might be jumping through hoops just to learn something different. Okay. Yep, ticket model looks like this. One thing is missing. We need an identifier, something unique about the ticket. So we found the model. Okay, we got this guy. But we don't want the ID before creating the ticket. So it can therefore go to have it optional. It's not ideal. Yeah, we don't avoid optionals if you can. Because then you have to always check to see if the ID's there. Okay, so then best solution is to have 2 different ticket states. Okay. Yeah, a draft also doesn't have a status. You're just creating it. That makes sense. Like when you're doing CRUD operations. Makes sense to me. So you post something as a ticket draft, and then you're going to return the ticket itself so it has the ID and a status, like a default status or something like that. So do we have a ticket draft? We do. We do have a ticket draft. Okay, ticket draft hasn't been created yet. It doesn't have an ID. Yeah, it doesn't have a status. But it needs to be unique. This is where I get a little confused. So we're just going to jump to see what their solution is, because I might over-engineer it for what they want. Okay, so they are self-ID. They put a counter. Oh, in the ticket store. Right. Okay, I guess, yeah, sure. But it's not public, so you can't see it. Yeah, I see what they're saying. What's going on here? Method get not found for this struct. Okay. Why are you trying to find it? Okay, get ID. Oh, okay, so hub get ID is 64, yeah. Maybe option. What are we returning? A ticket? Ticket? Do we have that? So what we would do is we would say for item in self dot tickets. Is that what we call them? Yeah, tickets. Okay. So if the item.id equals the ID, return ID, sum item, else return none. Is that what we're trying to do? FN, there we go. ID, it's a ticket ID. Ticket ID. Yeah, okay. So just wrap it like that. Oh, but is this supposed to be a ticket ID? Let's go to the bottom, see how it's used. Yeah, ticket ID. Okay. Okay. This is a ticket ID. No need to wrap this. Okay. Okay. Takes a draft. Okay, so then this is the hard part. What did they call this? Let me go back up. Oh, we have some sort of incremental ID. So I'll just call it U64 here. So that means when we create the store, we'll have it set to 0. And when we go to use it, we'll just say that it is a self.incremental plus 1. Okay, and then we make a ticket. T for ticket. Yeah, struct. So we'll take a ID, be a ticket ID of the ID, a status of to do, status to do, and then the title will be the ticket.title. And the description will be the ticket.description. This will be ticket ID. Just trying to refactor here. Put this out of here. Okay, and at the end we return the ID. But we don't want to push on that. We push on T. And that all works out because we have derived copy and clone, so we could put these into here as copies. I think that's what we needed to do. Oh, interesting. Get this, unwrap it. So shouldn't panic is what this is testing. So cargo test. Oh, we failed. Works. Where did it not work? Oh, interesting. It's saying the left is not equal to the right. 1 and 1. Okay, so that's because it should not equal. Oh, right. Okay, go back. Every time we create something, we're just doing 0 plus 1 every single time. We're going to push onto here, and then we're also going to take self.this plus 1. Because it's a self-mutating. Yeah. All right, that's what needed to happen. And we're in, right? So you can see my mistake. This is my incremental counter. It is a U64. It's not the best solution, but it's a solution that works for this exercise. And we're just doing incremental ID. So every time we add something in, we create an ID object, like a struct. So we can make our ticket, and we push the ticket into the store, but then we also have this other field that we added. So we got to increment that. For the next time that add ticket is called, because it's all synchronous, meaning add ticket is only called once at a time. That's the idea. Oh, here we go. Love your Rust videos, gives you motivation. Awesome. Love that. Here, I'll give you one of these guys. Cool. Glad it gives you motivation. And maybe you see on the stream here, we're doing some more Rust. We're exercising for Rust. All right. Let's see. Let's do the next one. Okay. What do we got here? We got 2 states. Now we're doing index. Okay, implement index and index. Okay, so borrowed ticket ID, the ticket store. Need an index into the ticket stores, I think what it's saying. Oh, that's almost the same code I just wrote. Here's the get, find it. Okay, yeah, they did the iter. I did it a little bit differently in the last one. That's fine. Oh, I see. We want to implement index on the store so that you can use this syntax here. I don't usually do this one, so we might have to look this up. I can't remember the last time I did this. All right, implement index for ticket store. What do we got here? What do we do? Fn, is it not a function? I don't know. So borrowed ticket. that how we do it? Is that what it wants us to do? I don't have any autocomplete here. We're gonna have to look it up. Okay, next. Let's learn about the index trait. Okay. Here's the trait. All right, we have an output. Some sort of borrowed output. So yeah, we're gonna return a ticket as the borrowed output. So type output equals a borrowed ticket. I think that's what we're gonna want. Fn index. Whoop. Like so. Okay, maybe we do it like this because it's already borrowing from there. Okay. And what do we do here? Yep, it has an IDX. So that's our use size that we're passing in. And the associated type of an output. Oh, okay. Index will panic if you try to access an element. Okay, yeah, so it just stops the runtime, stops execution. So we do if, I guess we could just do self tickets index. Does that work? IDX is a use size, yeah? I don't think I did this right. So what's it saying? Oh, where is it? STD use size index? I don't know where it's at. So could we have a code action? So the code action I want is this one. It's an ops. IDX. And then this is I don't know what it should be. I think it should be use size. Then everything else goes wrong. So I'm definitely confused. Okay. Let's go look at the solution, I guess. I think we're like right around the corner from what the solution is. Yep, got the ops. Okay, so they import or use it at the top, qualified it. We're doing this one. Oh, borrowed. Oh, and it's a ticket ID? Okay. I guess that makes sense. So it's a ticket ID, right? Just like that. Oh, borrowed ticket ID, because everything's borrowed here in this implementation. So then we do like so. That's what they're saying would work. We're getting close. Oh, just self, not tickets. Okay. Index. Oh, I said index, but it should be ID. ID. Okay, it's not working because we also need to do from ops. What is this module? Operators. Yes. Index of ticket store or ticket store. Yeah. So same as this. Then fn index. The index is not a ticket store. It's a ticket ID. We would do yeah, self dot tickets dot iter, and then we filter. We find. Is there a find? Yes, we find. Item dot ID equals the given ID dot collect. What did we do? We're close. We're so close. What do we do? Oh, unwrap. We want us to unwrap. Okay. Oh, instead of index, that's right. ID here. Oh, we're so close. We're so close. What did we do wrong? That ticket store cannot be indexed by ticket ID. Ticket store cannot be indexed. Yeah, I can. Look. Index. Just call this index. Oh, now we have something up here that's wrong. Expect the ticket store? Doesn't make any sense. Oh, borrowed. Maybe that's it. I know. I know. Nope, I don't know. Let's maybe take this away real quick. Still doesn't work. Why is that? Because we need this? Ticket ID. Yeah? All right, let's just copy and paste this and compare it to what we have written. Because I feel like what we have written is the right thing. Okay, I'm gonna paste it below. So does this have the same issue? It doesn't. So what in here is different? Self tickets iter find. We're calling theirs ID. We'll call ours ID. That's what we did first, right? So how is this different? Oh, I see it now. What are you indexing by? You're indexing by ticket store. Okay. Okay, let's get this out here. I think I got this. Ah. So ticket ID, which gives this the ID, but we're doing it for the ticket store. So ticket store is the self. The output will be an ID, and we're indexing with a ticket ID. That's what that means. Now we do the borrowed type. So this is not ticket store. This is ticket ID. That's where I totally went wrong. There we go. This would have been tricky though. I got, well, maybe not. I maybe would have guessed to dereference it because we have this here. Nice. Cool. Let's run the test though. Let's just double check. Maybe there's something else we got to do. Nope. Tests run just fine. Nice. All right. All right, guys. Thanks for tuning in for the stream today. This was the dev method. My name is Ricky. We went over 100 exercises in Rust. Not all today, just over a course of so many parts. Today was the longest stream that we've ever done. Why don't we real quick just recap what we did. And we'll use the website to do that. So we are doing 100 exercises to learn Rust. The link's in the description. You can go to rust-exercises.com/100 exercises to get the more detailed descriptions of what each of these exercises, what you should be learning, what you should be taking away from it. There's also a solutions branch, so you can get there. I did not create this. Is there anything else I need to let you know about? That's about it. So we'll do more. We'll finish up what we did. So we did intro, we did basic calculator, did ticket v1, traits, we finished tickets v2, and then we started the tickets management today. We did intro, arrays, vectors, resizing, iterators, iter, lifetimes, combinators, infiltrate 2, slices, mutable slices, 2 states, and index. Tomorrow we'll pick up at index mutable index. Then finish it out with hash map and B-tree map. Exciting. I've done hash map before, but hey, B-tree map sounds fun. All right. So yeah, thanks for watching, guys.